Hi everyone, my name is John Russell and I'm a developer advocate with AWS. I work with the Amazon Aurora database. Today I'm going to talk to you about the Babelfish for PostgreSQL open source project. Babelfish is a project that helps you to port legacy TSQL applications to a modern platform based on PostgreSQL. I'll do a full walkthrough showing how you can get an Aurora PostgreSQL database running integrated with Babelfish. Wouldn't it be great to have one database server that listened on two ports, each accepting a specific SQL dialect? That's what Babelfish for PostgreSQL does. It listens on port 5432, that's the port you connect to for Postgres and all its SQL features, and it listens on port 1433, that's the equivalent port for the SQL dialect known as T-SQL. Spoiler alert, that's what we'll end up with at the end of the demo. This terminal session shows what that will look like when the exercise is successful. We'll start by going into the AWS console for the RDS service. And then into the page that lists all of our databases. As you can see right now, we've got 0 databases in this AWS region. Nothing for Aurora or for any of the other kinds of RDS databases. I know from reading the Amazon Aurora documentation for using Babelfish that there are some prerequisites, some other things we're going to need to choose or create along the way. But I have confidence that the AWS console will do all of that for me, so I'll just dive right into the Create Database procedure. At the end of this procedure, I'll consider it a success as long as I end up with a working database server. Therefore, I'm going to pick the very minimal set of options needed to get a database server up and running with Babelfish. For this first choice between Standard Create and Easy Create, Easy Create won't give us the choice to turn on Babelfish, so I'll stick with Standard Create. To use Babelfish, we definitely have to pick Amazon Aurora as our overall database type. For the addition, we want the Postgres-compatible Aurora. Babelfish requires the Postgres-compatible addition. There are some version prerequisites for the Babelfish feature. For any major feature that requires particular versions, it's going to have a little slider here under the filters. We'll just show the versions that make sense to use with Babelfish, and now we have a very small set of versions to choose from. I'm going to pick version 14.4. Babelfish is so new and fast-moving, it's always best to have the very latest and greatest version. The most recent major version of Postgres-compatible Aurora is the one that picks up all the new features. I don't need a super powerful database server because for this exercise, I'm just going to use it for a very minimal proof of concept. So I'll pick development and test as my basic set of options. For my cluster identifier, I'll pick something descriptive, saying it's Babelfish enabled, Postgres compatible, and running Postgres version 14. For the credentials settings, the master username is the user that I will use to connect on both ports, so calling it Postgres doesn't quite make sense. Let's call it administrator. Admin happens to be a reserved username for Aurora. For the administrator password, I'll choose something myself. For the database instance class, I'm going to choose something that doesn't cost very much. It'll be t3.large. I wouldn't choose something with so little RAM if I was putting it into production, but just to try out the basic functionality in a developer environment, that's a low-cost option. For availability and durability, again, if I was going into production or had business-critical data, I would choose multi-AZ deployment. But for development and tests, I don't need the expense of a second database instance. With the way Aurora separates the compute capacity from the data storage, even if my test instance was destroyed, I could create a new one and attach it to the same cluster volume that contains all my data, so everything would still be safe. It would just be a few minutes to recover in that case. I'm just going to try out this database server from my own laptop that doesn't have any special network settings. So I'm not going to set up connectivity to an EC2 instance, although that is an intriguing option that's fairly new. If you run database applications or SQL clients on an EC2 instance, you should try out this setting. I will use the default VPC that I have for this region and the default subnet group. These are things that I didn't have to consciously create. They already exist in this region. For public access, I'll say yes. As I said, I do want to connect to this server from my laptop, which is not inside any VPN or corporate firewall. Let me emphasize that the best practice is definitely to pick no here. For this demo, it's not a production system, not business-critical data, no personally identifiable or other sensitive information. I'm just trying out the functionality, sort of a hello world for both of the SQL dialects I want to demonstrate. And I'm going to delete the database server at the end of the demo. For security, I am going to create a new security group, and in there I'll specify that only my one IP address is able to connect to this database server. I'll give the security group a name that makes clear that it's only for this one demo cluster. Availability zone. I think AWS can make a better choice for that than I can. We'll leave that alone, no preference. Database port. I'll use 5432 because that's the well-known port for Postgres. Every Babelfish-enabled Aurora cluster uses Postgres as its database engine. Now, here's the part that's unique for using Babelfish with Aurora. Check this checkbox, and that turns on Babelfish support in this cluster. It also brings up some other choices related to Babelfish, and all of those choices get saved in a parameter group so you can reuse them for other database clusters. Those other Babelfish choices appear a bit farther down. We'll set some other options in the meantime. For a throwaway database instance for this demo, I'll just use basic password authentication. Because I'm keeping costs low and I'm using a database instance class that has relatively little memory, I'm going to turn off any feature that isn't needed for the basic functionality testing in this demo. I'll turn off things that require memory or storage, like performance insights and enhanced monitoring, even though I would enable them if I were using this server for real performance or development work. Now, the only choice here for cluster parameter group is to create new, because I haven't done anything in this region up to now. So there is no existing parameter group to pick. The console is going to create the new parameter group, and it's already picked out a name based on the name I chose for this cluster. For my experiments, I might want to create several databases all on the same server. I'll choose the multi-database option. That'll give me flexibility to be able to create multiple databases using the TSQL side of things. The Babelfish TDS port will leave as 1433. That's the familiar port for T-SQL. All the Babelfish specific settings are in the cluster parameter group. Therefore, the DB parameter group, which is more for diagnostics and troubleshooting settings, will leave as the default. Because I only have a single database instance that I'm creating, remember I didn't pick the multi-AZ option earlier, failover priority isn't relevant. For backup retention period, I'll choose something very short because I'm going to delete this database cluster after the demo. Encryption I'll turn off. For this simple demo, no need to deal with encryption keys. Log exports. Let's turn that on so that I can examine what's happening behind the scenes and see any kind of errors that are being generated during the cluster setup. Although this is going to be a short-lived database cluster, so I don't expect there to be any upgrades needed, but automatic minor version upgrades is a nice setting to have enabled, so I'll leave that on. Maintenance window, that's not really relevant in this case. Deletion protection I leave turned off because I may even delete this database server the same day that I create it. I probably will run through this process more than once, perhaps making other choices as I learn what's really appropriate during my experiments. Let's go ahead and create the database server. In Aurora terminology, I'm creating a cluster, even though I only asked to create a single database instance. What we end up with, back in the list of databases, is the Aurora cluster. That's the top-level object that manages the storage in one or more database instances. Underneath that cluster is my single database instance. As I said, for my development and test environment, I'm not prioritizing high availability. If I was, I would have chosen multi-AZ back in the Create Database settings. And then there would be 2 database instances in the cluster, with the second ready to take over from the first in case of a hardware failure or data center outage. Now the cluster and its database instance have both been created successfully. Let's make sure that we have everything we'll need to be able to connect. First, we'll retrieve the details that we'll need for connection parameters or connection strings. We'll need to know the writer endpoint, also known as the cluster endpoint. That's what we'll plug in as the host name or server name when we're specifying connection settings for a client program. We'll also need to know the name of a user to log in as. Aurora created one, the administrative user, during the Create Database process. In this case, the name that I chose during the Create Database process was Administrator. I would create other users with their own passwords and permissions inside the database through SQL if I was using this database for real work. The other thing to double check for connectivity is the security group. That's associated with the database instance, which we see down here. In fact, this aspect of the network configuration is part of the EC2 service. You use the same mechanism to allow or block network access to EC2 instances and RDS and Aurora database instances. This security group is being created as part of the creation process in the console. And this is going to define who exactly is allowed to connect to the database, not from a password point of view, but from a network perspective. The way that we fine-tune the security group settings is by doing Edit Inbound Rules. We see that the Create Cluster dialog in the console has automatically created a rule for Postgres traffic on port 5432. It's detected my own IP address that I'm coming in through. 32 is the most restrictive number that you can put as the suffix here. That means that IP address and only that IP address is allowed network access to that database server, no IP ranges. Now I'm going to want to connect to the TSQL port. I'm going to add another rule. That one is labeled MSSQL. It's for port 1433. That's for the TSQL dialect. We'll specify again that only my IP address is allowed to connect to that database server. Other IP addresses won't even be able to ping it. They won't know it exists. Locking down the security group tightly, that's the secret anytime the public accessibility flag is turned on. Once I save these changes to the security group, everything should be in place to log into our Babelfish-enabled Aurora cluster. At this point, if I was acting as an administrator, I might declare victory and stop right there. With Aurora, you don't need to actually connect to the database for a lot of the administration. As an administrator, you can use the RDS console to create, configure, backup, restore, monitor, do all those sorts of things to the database server without actually being able to read or change the data. But for this demo, I'm acting as a developer. I'm going to go the extra step of connecting and running some SQL in both dialects. That's why I configured the security group to be able to connect to the database server from my laptop. I'm going to connect to both the PostgreSQL port and the TSQL port and demonstrate that the database server can process both SQL dialects. For this final part of the demo, We'll switch out of the console and over into a terminal window. I'll use the SQL command client for T-SQL and the PSQL client for Postgres. Both of these clients are available for Windows, Linux, and Mac, so you can follow these same steps no matter which platform you're familiar with. The big benefit of Babelfish is the way it understands the TSQL dialect and the TDS protocol, so let's take a look at that first. Back in the console, I copied the connection settings, like the host name and the administrator user ID. I've assigned those to environment variables. I'll pass those values as parameters to both the TSQL and Postgres client programs. I'll run a few statements to show some things that will look familiar to someone who uses T-SQL. Executing statements with Go, a built-in function, creating a table, and then querying it. Getting the list of available databases, and checking which database I'm currently in. Now I'll connect to the PostgreSQL server using the PSQL client program. Again, my connection parameters include the host name and administrative user of my database server. I copied those out of the AWS console. PSQL uses port 5432 by default. Postgres database servers typically contain a default database named Postgres, so that's the database I'll start off in. In Postgres, I can run the same types of statements as in the TSQL session, but now using Postgres syntax, function names, meta commands, and so on. In the list of my databases, one of them really jumps out, Babelfish DB. That's the database containing all the tables and metadata for the Babelfish support. I'll connect to that database and browse around there. In terms of the PostgreSQL structure, there are several schemas inside the database. Master DBO holds all the schema objects that were in the master database that we saw in the TSQL session. Here are the tables that are in the master DBO schema. See how some of the column types are user-defined, like sys.tinyint and sys.datetime? Babelfish defines these types in Postgres to match the semantics of the corresponding types in T-SQL. Seeing the schemas with Babelfish names and the information schema suggests to me that creating objects and data, running DDL and DML in TSQL is actually setting up extra metadata that I don't fully understand yet. So until I read more about interoperability, I'm going to do all DDL and DML on the TSQL side and only run queries on that data from Postgres. Here's a query in Postgres to read the table that was created and populated in T-SQL. That's the end of my demo of Aurora plus Babelfish. But wait, there's one more thing. Remember, I'm a developer who's just trying out this technology for the first time. I don't need to leave the server running 24/7. That would cost money. Here's what you can do if you don't need to use the server overnight or over the weekend, or when you're entirely finished with it. There's a stop action that applies to each Aurora cluster. You don't get billed for database instance hours while the cluster is stopped. It typically takes a few minutes to stop the cluster and a few minutes to start it again when you need it. Aurora auto-starts the cluster after 7 days, because if you could leave it stopped forever, it would fall behind in terms of software updates and other maintenance. But this is a convenient way to cut costs when your dev test database is idle overnight, over the weekend, or while you're on vacation. If you don't need the database cluster at all anymore, you can delete it. When trying out some new technology, you might go through several cycles of creating Aurora clusters with different settings and deleting the earlier ones. In the AWS console, you can add or remove multiple database instances from an Aurora cluster. When you delete the last database instance from the cluster, that has the effect of deleting the cluster too. If you're using the AWS command line interface, you actually have to do an extra step yourself to delete the cluster after all the database instances are gone. This extra choice of Create Final Snapshot is asking whether there's any data in this cluster that's worth preserving, in case you want to set up the same data again in the future. For my demo instance, where I only had that one toy table, I say no. If I had loaded hundreds of gigabytes of data to use in benchmarks, I'd say yes. Then, instead of going through the Create Database dialog, I do Restore Snapshot to create a new cluster with that same data. At the end of this video, I hope you understand the basic steps of getting ready to use Babelfish with Amazon Aurora. Now you can start migrating and running TSQL applications. I'll explore that subject in more depth in future videos. Thanks everybody for watching, and good luck with Babelfish for PostgreSQL.